This is my mobile irrigation pump power shed. And this is the 2 horsepower irrigation pump. I like the power with it. On one side, I have the DC inputs. This is the solar from the rooftop array. There's one array, and there's another array on the other side. This is the DC input for the solar panel that is affixed to the roof. On this side is the AC input and output. This is the water pump outlet. This is the generator inlet in L1430. And these are 2 120 volt plugs output. And then this cord goes to an auxiliary charger. You'll see in a second. And this pad area is for a generator or a water pump, whatever you fancy. All right, so listen y'all, it's gonna be messy. This is proof of concept, not finished product. Here's an overview of what's inside the pallet. Let's start with, this is the screen for one of the BMSs for the battery management system. Here's the battery management system, and it shows the current status of one of the batteries. There are 2 batteries total. So the second battery has a status indicator. That's this red light that shows that it's working. Here's for the inverter control panel. It shows you its status and what's going on. These are the DC breakers for the charge controller. This one is the charge controller. This is for temperature control. I have RV tank heater pads that keep this at a stable temperature year-round to where in the wintertime it doesn't get below freezing. It ensures that the batteries don't get below freezing when it is below freezing outside. This is the DC breaker for the inverter, single charge controller for the single panel, larger charge controller for the larger solar array on the roof, and then a Magnum 4448 PAE inverter. Over here is a contactor that is wired up to a timer switch to run the water pump, and then it's wired to this outlet here. Here is an auxiliary charger that will make sure that the batteries don't go below a certain voltage whenever the grid power is present. That way you're running everything on the inverter power that's being charged from solar power, and anything above a certain voltage it'll use solar for, but then when there's not enough solar, it'll ensure that it doesn't get below a certain voltage. The solar array on the roof is 12 Solar World panels. I think they're around 300 watts or so. Hooked to a Midnight Classic 150. This is the battery that we're using. There's 2 of them. We're using 2 JK BMSs that are 150 amp rated, and I wouldn't go any smaller, and I would definitely have 2 of them to be able to handle the surge capabilities of the inverter. The person out here is an older fella that doesn't have a cell phone, but for the millennials, here's a charging area, and this is for the water pump timer. You can hear the contactor clicked on and then clicks off. Here is the auxiliary battery charger. It is set to 50 volts to charge, and it shows you the voltage above that and how much amperage it's pulling. You can see that it's above 50 volts and is not pulling any amperage. This is how we keep the batteries heated. It has a thermostat built in, so you don't need any additional thermostats. It's very sexy. This is a 12 volt application heater pad, and the battery that we're running is a 48 volt battery. So you have a DC to DC converter that automatically brings it to 12 volts. This is a DC to DC converter, and it gets the job done. In the summertime, this thing can get pretty hot, as you can imagine, running all these electronic components and sitting out in direct sunlight. So I have two greenhouse shock absorbers that automatically erect and get flaccid as the temperature changes. As it gets really hot, it comes out quite a bit, and as it gets cooler, it goes away. Amazing. Is a small solar charge controller. You can see it is putting out 181 watts right now, just from the panel on the roof. One thing I would like to point out about this charge controller is that you absolutely need to learn how to program it accordingly. Otherwise, every time it loses solar power, aka when the sun goes down, you'll need to reprogram it when the sun comes up every single time, unless you reprogram it correctly. Also, pretty much everything that I've brought out here is covered in a not so thin layer of poop. Now that you see all of the components that are in the pallet project, I would like to discuss the issue that I'm running into. This is a 2 horsepower pump, as you can see right here, and it doesn't matter if it is primed with water in it or empty with no water anywhere to be found with all the hoses unhooked. It pulls 16,000 watts upon startup, and the inverter inside is amazing, but it's only rated for 8,000 watts maximum inrush. And so I've been really looking for a soft start motor controller that can handle this type of motor and application. After many nights awake scrolling through the internet, this is what I figured out that would work, so I thought. Because if you look at the side, it'll show you 230 volts AC. I have tried to have the motor using these two terminals where only one is being controlled via the soft start, and that does not work at all. I have tried this one and this one. That doesn't work either. If you look at line 1 and line 3, you can see that they have the ramp up and ramp down per shown in the wiring diagram, where the middle one does not have any control over it, but it doesn't matter how I've hooked it up. I run into the same issue where it does not start at all. So I would like to ask the internet if anybody watching this video knows of a good 2 horsepower soft start for 240 volts AC split phase. Please, I will happily send you money for any information that would work for this application. The roof is on hinges, so it's very easy to access all the equipment and make changes as you will need them. Alright, this is where the AC comes into the barn. You know, it's a mess of wires, but the contactor wouldn't fit the other way. So it's a normally open and normally closed contactor, and the way it's wired is if it has the inverter power coming in, it'll activate the coil and start running on the inverter power, and then if the inverter shuts off, it'll automatically revert back to grid power because it has refrigeration on the circuit, and so it needs to be always powered, as you can imagine. I have worked on this project over the past 6 months or so, and it has been a lot of time that I've spent on this. It may look very simple, at this stage, but I have put a lot of time into this project and I hope you enjoy. Thank you. Goodbye.